Hi guys, welcome to my basement. This is our first episode of Quarantine Physics Demos. It's my first demo that I'm going to do in the basement with it. So I want to show you a demonstration of this idea of conservation of angular momentum. So we've been studying angular momentum. We've talked about kind of what it is, and it's still kind of hard to understand, but I feel like after watching the Minute Physics video, the whole idea is really it allows us to understand why and how things move the way they do in a rotational sense. So I wanted to use that opportunity to do a demonstration here, and I'm going to have my daughter Lydia help me out. I'm in my desk chair, so I'm going to pick my feet up off the desk chair and sit kind of like a cross-legged. She's going to hand me the dumbbells here, and then we're going to spin around, and I want you to watch what happens. So, Lydia, you can come on in. Say hi to the camera. Okay, come on in. So hand me, these are 20 pounders. So, go ahead, give me the other one. That's good. Okay, so Lydia's gonna get me spinning as soon as I get my arms out. She's gonna get me spinning, and be careful. And then I'm gonna pull my arms in and you're gonna see this conservation of angular momentum in action. So, go ahead. Give me a spin, and hurry up, because these are heavy. Go! Faster! 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 Okay, watch out. Whoa! So way faster when my arms are in. Put my arms out, go way slower. All right, so in school, I'm still dizzy. In school, I could do this demonstration for you. We have a little platform to do it on that has ball bearings. It works a lot better than the chair, but even with the chair it still works. And using the heavy weights is helpful because by putting my arms out with those heavy weights really increases my moment of inertia by a lot. So with a much larger moment of inertia, it's a lot harder to spin. When I bring my arms in, I'm concentrating that mass close to my axis of rotation, so I'm decreasing my moment of inertia. But you got to think about what we talked about already with angular momentum. In the first part, when Lydia was pushing me, she was exerting a force on me and causing me to rotate. So that's an external torque. So when she's exerting that force on me, my angular momentum was changing. I went from having no angular momentum, sitting still, to having some angular momentum when I was spinning. Then I told her to stop pushing. When she stopped pushing, that external torque was gone. Now, if we ignore the frictional torque in the axle of the chair, there is some friction, but it's small. If we ignore that, then once Lydia stops pushing on me, there's no external torque acting on the system of me and the chair anymore. So I'm spinning around like this, and I have some angular momentum. When I pull my arms in, me pulling my arms in is not an external torque. So my angular momentum doesn't change. But pulling my arms in does change my moment of inertia. So if my moment of inertia drops and my angular momentum stays the same, then what has to happen? I have to start spinning faster as a result. This is the same thing that happens to planets. If you think about Kepler's second law, when planets get closer to the sun, they're moving faster. When they're farther away from the sun, they move more slowly. That's a consequence of conservation of angular momentum. Kepler didn't know it at the time, but that is a true statement. If you look at when a star collapses to form something like a neutron star or a black hole, they spin a lot faster for the same reason. You're concentrating all this mass, you're making the moment of inertia a lot smaller, but the angular momentum is still the same because there's no external torque acting on the system. So we see both kind of key ideas about angular momentum here. The first, where if there's an external torque from somebody pushing or an outside force or something like that, then the angular momentum will change. But if there's no external torque after Lydia stopped pushing, my angular momentum stayed the same, but the moment of inertia went down, so the angular velocity went up to compensate for it. So I hope that makes sense for you. I hope you enjoyed it. You could try it with a spinning chair. Be careful. We had kids a couple of years ago kind of fall out of their chair in school. demonstrating this, so be careful if you're going to do it. But hope that helps to make sense of it, and I'll talk to you about it soon.